Okay. How are you guys doing? How's everybody doing? Okay. All right. It's 8th week. This is when things start to get hard. So the midterm 2 grades have been posted, as I'm sure many of you guys have figured out. If you'll indulge me, there's just a few things I want to say about midterm 2. Okay. So first of all, the class average the median was an 84, which I think is very good. Over 25% of you, like the Q1 was like a 92, and like a bunch of you guys got 100 and 104. So that's great. Okay, I'm very proud of you guys who did very well. Good job. And I also know that many of you didn't perform as well as you might have hoped. Okay, and maybe you're questioning, just like, what's wrong with me, or what am I doing wrong, or something like that. Okay, and I just want to put things in perspective here. Okay, first of all, your value, your worth as a human being is not tied to any test or any academic performance or any like grades in class. Like these things, like in the grand scheme of life, honestly, they don't really matter. Okay, like some of you are like planning to go to medical school or things like that, and grades may be a little bit more important. But even then, your performance on a single test, whether it's good or bad, in the grand scheme of things, it's not what's important in life. Okay, who we end up helping out, how the love we give back to the world and community, that's much more important. Okay. Second, if you're working hard and you didn't do that great on the test, there's no shame in that. Okay, there's no shame in working your butt off, studying, and not doing as great as you had hoped. It's disappointing, yes, but if you're working hard, you're doing everything right. Okay, you don't feel bad about it. It's my goal to get everybody to do well, and I'm hoping to teach and present the material in a way that will help you understand. At the same time, certain concepts are just hard and difficult to grasp, and there's no shame in struggling. So anyway, I just wanted to say that we still have a final exam. There's still work left in the quarter. This is where I think the class gets extra interesting, when we get into statistical inference. So I'll do my best to explain everything and give you everything you need to succeed. And if you're working hard, then you're doing everything right. Okay. Many of you want to review your midterm exams. I'm sorry, I don't have them ready today. So I know some of you guys emailed me over the weekend. I was actually out of town this past weekend, so I don't have them ready for review today, but I will have them ready for review on Wednesday. And I'll hold 2 hours of office hours on Wednesday. I'll have them from 11 to noon and also from 3 to 4 on Wednesday, so you can come by to take a look at your exam and things like that. Okay, but I apologize, I don't have them ready today. If you want to come to office hours and you just have questions about material in the course, I'm more than happy to help you out there. Okay. Any other questions or concerns or issues? Yes. Is the final cumulative? Slightly, I guess. I'd say it's going to be 80% focused from stuff after midterm 2, and maybe 20% stuff from throughout the course. Okay, but the 20% of stuff is going to be mostly conceptual stuff, things that won't require a ton of calculations. But I don't know, stuff maybe like, they'll say like, I don't know, what kind of data can be displayed in a dot plot? And you would tell me numeric data or something like that, okay? So, yeah, all right, anyway. We'll get through this. Okay, we are moving into chapter 8. Okay, and this is on hypothesis testing. Okay, and so this is statistical inference, and so we are, we will try to answer questions about the population based on limited data, okay? And the way hypothesis testing works is we begin with a kind of a claim or a question that we want to test, okay? So we start with a claim or question that we can test. Okay, and this is and this claim or question, this is the hypothesis. Okay, and then we also have data. Okay. And then we have data. Okay, and the test comes down to this. We say if some claim were true, what do we expect our data to look like? And then we compare what we expect our data to look like versus what the data actually looks like, and we ask, are these two things vastly different, or are they close enough? Okay? So we ask, if the claim were true, claim or hypothesis were true, what would we expect our data to look like? Okay? And we compare our expectation versus the reality. Okay? So we compare the reality or the expectation versus the reality. Okay? And if they are really different, then that's an indication that our hypothesis is not true. And if they are similar, then that would tell us our hypothesis could be true. Okay? I'll say greatly different. If they are greatly different, that is an indication that our hypothesis is likely to be untrue. And if they are not very different, our hypothesis might be true. Okay, and this is kind of the big picture behind hypothesis testing. Okay, so let's try out a silly situation here. Okay. Okay, so let's say you are playing a game of chance with a friend. Okay. It's a very silly game. You're just going to be flipping coins, okay? So you're playing a game of chance. With a friend, okay? We'll put quote-unquote friend here. All right. And basically, heads, you win, tails, he wins, okay? So you flip a coin. Okay? Heads, you win. Tails, he wins. Okay. All right. And then, okay, so let's say you play 10 games. Okay. How many, if the game is being played fairly, how many games do you expect to win and how many games do you expect to lose? 5, right? Okay, so let's say you play 10 games. Okay, so if the game is played fairly, okay, we expect to win 5 games, or we expect a win rate of 50%. I'll just say 0.5, okay? All right, and so let's say in all of these games, he's the one doing the coin flipping, okay? So he flips the coin 10 times. Okay, and let's say it lands heads 3 times, or 0.30 with a proportion of 0.30, okay? All right, so that's less than what we would have expected, right? We were expecting around 50%, we got 30%, okay? Do we feel like the friend is cheating, or do we feel like maybe I just got unlucky? Cheating? Okay, well, probably at this point we would just say, I mean, he could be cheating, but it's also quite likely that we just got unlucky, right? Like, we're not ready to say, you're cheating, I only won 3 times, what are you doing? We just say like, okay, maybe I just got unlucky, right? So, you know, so we might say, we just got unlucky, okay? Perhaps we were unlucky. But could the friend be cheating? The friend could be cheating, okay? We don't know, okay? We only played 10 games. It's hard to tell at this point, okay? Perhaps we were unlucky. So this is one scenario, okay? I'm just trying to show you that we have already a little bit of an intuition behind hypothesis testing, and we can just kind of expand this intuition to a bunch of other settings, all right? Okay, scenario 2. Same thing. This time, though, we are going to play 100 games, okay? And if the game is played fairly, we expect to win. I'm sorry, we're going to play 1,000 games. Okay, so we're going to play 1,000 games, and if the game is played fairly, we expect to win 500 games, about 500 games, okay? We expect still a win rate of 0.5. Okay? So this time our friend flips the coin 1,000 times, and it lands heads only 300 times, okay? So he's doing the coin flipping. And he flips the coin 1,000 times, and it lands heads 300 times, okay? So, you know, we're expecting a win rate of 0.5. We observe a win rate of 0.3, okay? So this time, are we going to say perhaps we were just unlucky? No, this now feels very suspicious, right? You say, well, you did all the coin flipping. I don't know what you did, but this just doesn't seem quite right, okay? So we're not going to say perhaps we were unlucky, okay? So this is not going to be our response. We're going to say, I don't know what you're doing, but these results do not match what we're expecting, right? Like we're expecting, like if the game is being played fairly, we should win around 50% of the time. The fact that we only got 300 wins, this is a strong indication that something is wrong, okay? We have a gut feeling right now, okay? So, you know, we have a gut feeling that something is wrong, okay? So we suspect some cheating is going on. Okay. All right, so what if the friend just said, no, I just got really lucky. I flipped the coin 1,000 times. I promise it's fair. I just got really, really lucky. What would you say? Why would you not believe your friend when he says, when your quote friend says, I got lucky? Yeah. Yeah, we'd say, okay, well, just for argument's sake, let's say you did get really lucky, okay? We can actually find the probability that random chance will produce basically 300 wins for us or 700 wins for him, okay? We could say, if you truly were playing fairly, what is the probability of these results, okay? And we would find out the probability of getting these results from random chance is extremely, extremely unlikely. Okay? So I'm going to just go to the next slide. So, you know, again, the results are 1,000 games and only 300 wins. Okay, and then the friend says, no way, I'm not cheating. I'm not cheating. You just got really unlucky. You were just really unlucky. Okay? So we counter. Okay. Let's say you are playing fairly. Okay. Okay. What is the probability that I win only 30% of the games? Okay. Okay, and it's actually win only 30% or less. Because if we accused him of cheating for winning only 300 games, we would also accuse him of cheating if we only won 299 or 298 or anything less than 300, okay? So at 300, we're willing to accuse him of cheating. We'd also be willing to accuse him of cheating if we won anything less than that. So can we answer this question? We can, okay? And I'll turn this into a question that you guys can answer, or at least give me the z-score associated with what we have, okay? So find the z-score. Okay, which is you played 1,000 games and you only won 300 games. Okay, so find the z-score associated with winning only 300 games out of 1,000. Or I'll say with winning only 0.3 of the games. 0.3 of the games, okay? So keep in mind, we're looking at the distribution of p hat, which is a normal distribution, okay? If the game is being played fairly, we would expect our sample proportions, the percentage that we win, to be around 50%, right? And we would have a standard deviation of 0.5 times 1 minus 0.5, which is also 0.5, divided by 1,000. Okay? And we want to know what's the probability of being down at 0.3. Okay, so what's the z-score here? And let me give you some, we'll turn this into a clicker question. Somebody clicked E. Okay, just a few more seconds here. It looks like most of you guys are doing this correctly. So get your clicks in. So I'm going to hit stop. Okay, and indeed the answer is D. Okay. Okay, and so let's just kind of take a step back and make sure we understand what we're doing. Okay, so we're saying, okay, for argument's sake, let's say you are playing the game fairly. Okay, if you're playing the game fairly, we would expect to win about 50% of the games. So that's why our normal distribution is centered at 50%. Okay, and we're saying, okay, well, we played 1,000 games, and so our sampling distribution will be normal, and it's going to have this standard deviation, okay, which is what we learned when we learned about sampling distributions. Okay. And we said, okay, what does our data look like? In our data, we only won 30% of the games, okay? And so we find the z-score associated with this, and we find that we are over 12.5 standard deviations away from the mean. So remember, the empirical rule said, 95% is within 2 standard deviations and like nearly 100% is within 3 standard deviations. Okay, and we said like anything more than 2 or 3 standard deviations is unusual. And here we are at 12.5 standard deviations away from the mean. So this is a ridiculously far distance from the mean. So I know this is the picture I drew, but in reality the picture is probably more like, oops. It's probably like we're down here, and we're asking, how much is shaded over here? Okay, it's practically nothing. Okay, is it technically possible in the? It's not. Nothing is technically impossible, right? Like it's technically within the realm of possibility, but it's so incredibly unlikely that we say, I don't think this happened by random chance, okay? This is like 1 in a trillion, okay? So, so the probability associated with observing our data if the game were played fairly is extremely low. Okay? So this is, we're calculating the probability if we made this assumption that the game were being played fairly, okay? And it's extremely, extremely low, okay? But we observed this data, okay? And so the fact that we observed this data that has an incredibly low probability associated with it gives us an indication that the assumption that the game is being played fairly is wrong, okay? So the fact that we observed the data is an indication that the assumption of fair play is wrong. Okay. All right, and we already had kind of this sense of intuition. We said 1,000 games and you only won 300 games, something feels wrong about that, okay? You play 10 games and you won only 3 games, or what did I say? You play 1,000 games and you win only 300, something feels wrong. On the other hand, when you play 10 games and you win only 3, you feel like that could happen because of bad luck, okay, or chance, okay? And then, but then there's like a whole bunch of scenarios in between. What if you play 100 games and you win only 30? Is that an indication that cheating is going on? Or what if you play 40 games and you win, I don't know, 17 games or something like that, okay? There's a whole bunch of in-between scenarios, how can where we no longer have this gut instinct that that can really tell things for us, how can we answer this? Well, this is where the statistics methodology for hypothesis testing comes in. Okay, so rather than just going off of gut feelings, which we could do in these extreme scenarios, we can apply basically these statistical inference tests. Okay. Does the intuition behind a hypothesis test kind of make sense? Okay. So so I want to give you a few key like terms and things that we're going to do. Okay. So first we're going to start with hypotheses. Okay. And so we call this hypothesis testing because everything is centered around the hypotheses. Okay. And there's always, they come in pairs, okay? We always have the null hypothesis, and then we have the alternative hypothesis. And I'm going to give you the definition of both of these, but leave a little space. Okay. So the null hypothesis is often we call the status quo. The status quo scenario, or the one where generally nothing interesting is happening, okay? We create our hypotheses often with the hope of eventually rejecting the null hypothesis, okay? Not always, but, okay? So we often hope to reject the null hypothesis. Okay? The null hypothesis is written H0, okay? H0, all right. Also, the null hypothesis will always have an equal sign in it. Okay. So in the beginning, I think a lot of the hard part is trying to figure out what the hypotheses are. If you always remember that the null hypothesis will always have an equal sign in it, I think that will help in the creation of hypotheses. Okay. The alternative hypothesis will look exactly like the null hypothesis, except the equal sign has changed to something else. Okay. So this is and this is HA, okay? Looks exactly like the null hypothesis, okay? Except the equal sign has changed to something else. Okay, so either a not equal sign, or a greater than sign, or a less than sign. Okay. Okay. And all right. And then once we have our hypotheses, there's also a very key term, and this is called the p-value. Okay? And the p-value is the probability associated with observing our data So observing the data that we actually have. So the probability associated with observing our data observing our data or something more extreme. That's a key phrase that we have to keep in there. If we assume that the null hypothesis were true. Okay. So these are key parts with for any kind of hypothesis test. Okay, and so I'm going to we'll go revisit that problem with the coin flipping and the accusation of cheating, and I'll show you what the null and alternative hypotheses and p-value would be in these situations, okay? Do we have this all written down? Good. Okay, so we'll go back to our coin flip story. So we'll say 1,000 flips, 300 heads. And the question is our friend cheating? Okay, that's what we want to know. All right, so the null hypothesis. Okay, so our null hypothesis, I'm going to just write H0. I'm going to first write it in words, and then I'll put it symbolically. Okay, so the null hypothesis will be the game is being played fairly. Okay, and then the alternative will be the friend is cheating. Okay. Friend is cheating, basically to give him an advantage, or to give us a disadvantage. Okay, and this basically makes up the scenarios of possibility. Either the game is being played fairly, or something is going on. We don't know what, but something is going on to give us a disadvantage. So symbolically, okay, we would say our null hypothesis is that P is equal to 0.5, where P is the probability of us winning. So if the game is being played fairly, the probability of us winning is 0.5. Okay? What would the alternative hypothesis be? Okay? So the alternative looks exactly like the null hypothesis, with the exception that the equal sign has been changed to something else. Okay? And so P is the probability associated with us winning. So everything is exactly the same, except the equal sign is now a less than sign. Just want to make sure that the creation of our hypotheses is okay here. Does that feel okay? All right. Okay. And then, so the p-value in our situation is going to be basically the answer to the question, what is the probability that 1,000 games played fairly results in a win rate or sample proportion of 0.3 or less. Okay? This is the p-value. It's the probability So, you know, you can flip back to the definition of the p-value, but it's the probability of getting our data, or something more extreme, if the null hypothesis were true. Okay, so we're asking, what's the probability of getting this data? 300 heads, or something more extreme, so 300, a win rate of 0.3 or less, if the game is played fairly, if p is equal to 0.5, if the null hypothesis were true. Okay, and then so we did the math there, and we found out that that the p-value, or the z-score, you know, we're expecting 0.5, we end up out here at 0.3, so we get, you know, z is equal to whatever, negative 12.65 or something, and so the p-value is the probability associated with this, so the p-value is practically 0, okay? So almost 0. Okay, so it's the probability, what's the probability of getting this data if the game were played fairly? The probability of this happening is almost 0. Okay, is that okay? Okay, so let's, let me just create like a little problem, and let's see if you guys can figure out the appropriate hypotheses to use in this scenario here. Okay, can I flip the slide here? Okay, so we want to know, so does Apple have over a 50% share of smartphone users? Okay, this is what we want to know. Okay, so we get a random sample. Let's say of 100 smartphone users. Okay, and then we'll say, I have no idea what percentage. Does anybody know this, Steph? Okay, nobody knows, so it doesn't matter. All right, we'll say, let's say 54 of them have an Apple product, okay, or have an iPhone. All right. Okay, so now we'll say, what hypotheses would we use if we wish to know if Apple has over 50%, I don't know, of the market share. Okay, so we'll say P is equal to market share. All right, so your answers will be P is equal to 0.54, and the alternative is P is less than 0.54. We could say P is equal to 0.5. Let me just move this one over. So this is our last question here. And okay, get your clicks in. Get your clicks in. Okay, so just a few more seconds. I'm going to hit stop here very soon. Okay, I'm going to hit stop. And yes, and that is the correct answer choice. Okay, so we want, so the key here is, does Apple have over 50% of the market share? So we're going to assess, is P equal to 0.5 or is it greater than 0.5? Okay? All right, that's it. We'll see you guys on Wednesday.